Welcome to the deep dive. Today we're pulling back the curtain on a chemical you've probably never heard of, carbamic acid isopropyl ester.
Right.
But its story is, well, surprisingly central to our daily lives. We're going to trace its hidden journey through global markets, really understand its quiet power.
Mhm.
Our source for this deep dive is a really comprehensive analysis from cognitive market research. It's packed with the latest numbers, insights. It really paints a clear picture.
It does, yeah. It's quite detailed.
And here's the immediate aha moment, the thing that really caught my eye. Despite being, a truly niche compound,
Very niche.
the global market for it was valued at $35.9 million back in 2021. Okay, not huge maybe, but get this, it's projected to nearly double, soaring to $68.3 million by 2033.
Yeah, and what's truly fascinating here isn't just that doubling, though that's significant.
Yeah.
It's why. Why this seemingly obscure chemical, let's say we call it CAIE, just for simplicity.
Good idea, yeah.
Why it's so important. It's not a final product. You'd never find it on a shelf.
Yep.
Instead, it's what we call a strategic intermediate. Think of it like a highly specialized molecular building block.
A building block. Okay.
Crucial for synthesizing the active ingredients in, well, everything from vital pharmaceuticals that keep us healthy to the agrochemicals that help grow our food.
Ah, okay, so that's the connection.
Exactly.
Yeah.
Its specific chemical structure allows chemists to create complex molecules that frankly would be much harder, maybe even impossible, to produce efficiently otherwise. It's this quiet but absolutely essential contributor.
To industries that, profoundly touch our daily lives, like you said. Okay, let's unpack this growth then. The global market for CAIE isn't just expanding. The source describes it as experiencing gradual yet steady growth.
Steady is the key word there.
Right. Expanding at a compound annual growth rate, a CAGR, of 5.5% from 2021 all the way through to 2033. So this isn't some flash in the pan, is it?
Absolutely not. If you connect this to the bigger picture, that consistent, steady growth rate really underscores its foundational role. The demand from pharma and agrochem sectors isn't fleeting. It's a bedrock of continuous need. That ensures reliable market expansion over the long term. It signals, increasing reliance on these unseen building blocks.
Making the supply chain for everyday stuff more complex, I guess, but also robust.
Exactly. More complex, more robust.
So where are the hot spots for this unseen chemical? Let's zoom in a bit, dive into the geography, because like you said, it's not growing evenly everywhere. We're seeing some really dynamic regions leading the charge.
And some surprising movers, too.
Yeah, exactly. Asia Pacific, for instance, is not just a leader, it's practically the engine here, right? This region held the largest market value in 2021, $12.6 million. And it's projected to almost double to $24.6 million by 2033. That's a very healthy 5.7% CAGR, almost a third of the global market right there.
And within Asia Pacific, China is definitely leading the pack. Its market size is expected to reach something like $8.7 million by 2033.
Wow. Okay.
Which just showcases its continued dominance in global chemical production. Huge industrial base.
But here's where it gets really interesting, I thought. India.
Ah, yes.
India is seeing particularly rapid growth. Their market is projected to jump from $1.6 million to $3.7 million. And that's got the region's highest CAGR, 7.1%.
Yeah.
What's driving that? Why is India's momentum higher than, say, China's, even though China's bigger overall?
That's a great question. It's an astute observation. India's higher growth rate, it isn't just about scale catching up. It probably points to a more deliberate national strategy, boosting pharmaceutical self-sufficiency, maybe, and agricultural output. They seem to be investing heavily in domestic manufacturing capabilities.
They're thinking it up.
And perhaps leveraging lower production costs or, expanding into export markets that maybe aren't as accessible to others. And it's not just China and India either.
No.
We also see steady gains from Japan, South Korea, Australia, and the broader Southeast Asia region. That area alone is expected to hit $3.3 million by 2033.
So it's really broad-based expansion in Asia Pacific.
Really is, yeah.
Okay, moving over to Europe, also a key growth area for CAIE, apparently. Expanding from $7.7 million in 2021 to $15.3 million by 2033. That's growing at a robust 6% CAGR.
Yeah, Europe's strong too. And by 2033, you'll see the established economies like Germany, France, UK being significant contributors. Germany, around $3.2 million, France, $2.5 million, UK, $2.2 million. Then you've also got Italy, Russia, Spain, each contributing between, say, $1.2 and $1.5 million.
So a pretty diverse set of players there.
Reflects a
This audio was created with Podcastle.ai.
$1.2 and $1.5 million.
So a pretty diverse set of players there.
Reflects a mature but still growing chemical industry across the continent.
So what stands out? Luxembourg.
Ah, yes. Looks
It
good.
shows the strongest regional CAGR in Europe, an impressive 8%, reaching $1.1 million by 2033. I mean, that's a tiny country,
It is.
punching far above its weight in this specific market. What does that tell us about these specialized niches?
It's fascinating, isn't it? Luxembourg's high growth, despite its size, it often indicates highly specialized manufacturing, maybe R&D investment.
Right.
Perhaps they're focusing on very high purity grades of CAIE for specific pharma applications, or maybe leveraging strategic logistical advantages within Europe. It's a great example of how niche markets can have surprising regional powerhouses.
Really interesting. Okay, let's look at South America. This market's projected to more than double, from $1.5 million in 2021 up to $3.2 million by 2033. That's a strong 6.3% CAGR.
Yeah, robust growth there too. Brazil clearly dominates the region in terms of sheer market size, obviously, but it's worth noting the dynamic growth in places like Colombia and Peru. Both are projected to grow above a 6.6% CAGR.
Oh, wow. So even faster than the regional average.
Exactly. It indicates some, exciting high growth potential within the continent as their own agrochemical and perhaps pharmaceutical sectors develop.
Got it. Okay, over in North America, the market looks solid and steady. Forecast to reach $17 million by 2033, expanding at about 5.3% CAGR.
That's right. The U.S., as you might expect, leads the region, growing from $7.7 million in 2021 up to $14.1 million by 2033.
The lion's share, yeah.
But it's worth noting Canada's higher growth potential. It's rising from about $0.9 million to $2 million by 2033. That's a 6.5% CAGR.
So Canada's actually growing faster than the U.S. in percentage terms.
It seems so, yeah. Higher growth rate.
Yeah.
Mexico shows a more modest rise, reaching around $7.9 million. So, yeah, U.S. is the volume leader, but Canada's showing accelerated momentum.
Interesting dynamic there. And then the Middle East and Africa, this seems like a more varied picture, really shows the uneven nature of this niche market's expansion.
That's right. It's quite mixed. For example, Egypt grows relatively slowly, about 2.5% CAGR, reaching maybe $6.6 million by 2033.
Okay.
Whereas Turkey shows a bit more promise, reaching $6.9 million. But then the rest of the Middle East market remains quite small, growing at only like 1% CAGR.
Barely growing then.
Pretty much. And in Africa, South Africa grows modestly to about $2.4 million. Nigeria edges upward to maybe $0.2 million by 2033.
So it suggests that while there's some growth, maybe the infrastructure or the industrial development isn't quite there yet to fully capitalize on this specific chemical market.
That could well be the case, yeah. The foundations might not be as strong for this particular niche yet.
Right. So all these regional dynamics, they connect back to the overarching factors influencing this market. Can you maybe elaborate on those core drivers beyond just its role as that strategic intermediate?
Absolutely. Beyond its fundamental importance in pharma and agrochem, two really significant factors shape its market. One is regulatory challenges.
Okay.
And the other is stringent purity requirements. For pharmaceuticals, even trace impurities could lead to inactive drugs or worse, adverse reactions.
Yeah, you don't want that.
No. And in agrochemicals, impurities might alter effectiveness or leave undesirable residues in crops or soil. This means you need extremely precise multi-stage synthesis processes and rigorous quality control. Very rigorous.
That raises a really important question. What kind of regulatory challenges are we talking about here? Is it environmental stuff, safety, trade-related, and how does that impact who can actually produce this compound?
Well, it's a complex mix, really. Imagine trying to navigate this maze of different environmental standards for chemical waste disposal, worker safety protocols, import-export regulations across every single country you want to sell to or operate in.
That sounds like a nightmare.
It can be. These aren't just minor hurdles.
Right.
They significantly impact, plant design, operational costs, even just the barriers to entering the market in the first place.
Right.
Which often means that only companies with substantial investment in advanced manufacturing and regulatory compliance expertise can truly compete.
Which then influences that geographic distribution of production we were just talking about.
Exactly. It all ties together.
Okay, so let's recap our deep dive here. While this carbamic acid isopropyl ester market might be niche, kind of hidden,
Definitely hidden.
Its consistent growth and its vital foundational role in global pharmaceuticals and agrochemicals make it, well, a quietly powerful force in the chemical industry. It's much more than just numbers on a page, isn't it?
Absolutely. And if we connect this to the bigger picture, it truly highlights how these specialized chemical intermediates, often completely hidden from public view, underpin the massive industries we rely on every single day.
Yeah.
We often take for granted the complex supply chains that bring us our medicines or allow us to grow our food, but it's these specific high-purity compounds, like CAIE, that make it all possible. They're sort of the unseen heroes of modern industry.
Unseen heroes. I like that. So that raises an important final thought for you, our listener, to consider. Given the absolute importance of purity and the pervasive influence of regulations in markets just like this one, how might future advancements in chemical synthesis or maybe evolving global health needs, changing agricultural demands, how might those things impact the growth and development of such specialized, crucial compounds?
Good question.
And what does this tell you about the hidden complexities, maybe even the vulnerabilities of the products you use every day and the silent, intricate world that actually makes them possible? Something to think about.
Welcome, deep divers. You know, every day, our world runs on things we just don't think about, the food we eat, the medicines we might need.
Absolutely.
But what if I told you there's this one kind of obscure chemical intermediate that's actually quietly powering a lot of these vital industries? Today, we're pulling back the curtain on carbamic acid isopropyl ester. Bit of a mouthful, right?
It is. Yeah. But yeah, think of it less as a final product and more like a really versatile Lego brick, if you will, a fundamental chemical building block.
Okay, a Lego brick. I like that.
And our mission today really is to understand why this particular brick is getting so much, well, strategic attention now. What's its essential role, and what are the dynamics shaping its market? We're drawing insights from CAGR to market research here.
Right. And that's what we want to explore, how this...
This audio was created with podcastle.ai.
Market research here.
Right. And that's what we want to explore, how this hidden compound connects to the stuff that impacts your life, often completely under the radar. So let's dig into what's driving its growth. First off, its role in agrochemical synthesis seems absolutely crucial.
Oh, definitely.
We're talking about carbamate-based pesticides and herbicides.
Yeah.
You know, those chemicals used pretty widely to protect crops.
Exactly. And with the global population ticking upwards, there's this constant pressure to get more out of our crops, higher yields.
Makes sense.
So that demand for effective crop protection directly fuels the need for intermediates like carbamic acid isopropyl ester. It's sort of a quiet engine behind, well, global food security, really.
Wow. And it doesn't stop there, does it? You mentioned pharmaceuticals.
Yeah, what's really fascinating is how useful it is there, too. It's indispensable for making active pharmaceutical ingredients, APIs.
APIs, right.
Especially in the generics market, which is booming. Their cost-effective production of drugs that are off-patent is absolutely key.
So it helps keep those costs down.
It does. It really shows how the pharma industry is always pushing for, both innovation and affordability. A complex kind of niche chemical like this becomes this quiet cornerstone, enabling breakthroughs, but also those generic cost savings we rely on.
And it's not just these huge industries, right? There's also research.
Correct. We're seeing it pop up more in custom synthesis and broader chemical research, too. R&D labs, especially in life sciences and specialty chemicals, they're using it to build new organic molecules.
Driven by R&D investment, I suppose.
Exactly. Big investments, plus a growing need for CROs, contract research organizations, and specialty manufacturers to keep innovating.
Okay, so it's versatile, it's in demand, but there have to be challenges.
Oh, absolutely. And that brings us to some pretty weighty responsibilities. The first big one, it's inherent toxicity and safety risks.
Ah, right. Chemical intermediates often come with that territory.
They do. And improper handling. That poses real risks, both to human health and the environment. So you need really strict safety measures, storage protocols, proper disposal procedures.
Which all adds complexity and cost, I imagine.
Significant complexity and cost for manufacturers, yes. It's not trivial.
That really highlights the tricky nature of this market. And you mentioned purity earlier in the pharma context. Is getting the really high purity stuff a bottleneck?
It absolutely can be, yeah. The supply of those high purity grades, the ones you need for pharma and maybe some premium agrochemicals, it's limited.
So, few suppliers.
Very few, relatively speaking. And that can really strain the supply chain, makes it harder to scale up production quickly if demand spikes.
And on top of that, I bet regulations play a part.
You bet. Tightening environmental regulations, particularly in places like North America and the EU, they add another layer of complexity. Production, transport, emissions compliance, it all gets tougher.
It sounds like a constant balancing act.
It really is. Meeting demand while sticking to increasingly strict environmental standards.
So where does this market go from here? What are the emerging trends?
Well, looking ahead, there are some fascinating shifts. One really notable trend is towards green chemistry and safer alternatives.
Makes sense. Sustainability is everywhere.
It is, and those goals are pushing companies to explore more eco-friendly ways to synthesize things and maybe find lower toxicity substitutes for some traditional carbonates. It's about finding smarter, cleaner ways to get the job done.
Interesting. And geographically, any shifts?
Oh, big time. We're seeing the Asia-Pacific region, specifically India and China, really emerging as dominant players in production.
Right, there's lower costs.
That's part of it, yeah, competitive production costs. But it's also rising demand within the region itself, plus, supportive government policies that are actively encouraging chemical intermediate manufacturing. It's strategic for them.
Okay. And one last trend.
Yes, the growing pattern of outsourcing. We're seeing more companies turning to contract research and manufacturing organizations, CROs and CMOs.
Handle the synthesis.
Exactly. They leverage these specialized third parties to make intermediates like Carbamic Acid Isopropyl Ester. It lets the main companies stay agile, cut costs, and really focus their energy on core innovation and getting products to market rather than the tricky details of chemical production itself.
Okay, so bringing it all together, carbamic acid isopropyl ester, it's clearly way more than just another chemical on a list.
Absolutely. It's a strategic enabler.
Yeah.
Modern agriculture, pharma, cutting-edge research, it plays a key role.
It really makes you think, doesn't it? How many other vital but sort of hidden chemical intermediates like this are quietly shaping our world, driving progress in fields we totally depend on every single day?
What other unseen components are out there, really indispensable, making things happen behind the scenes?
Yeah, something to reflect on. That intricate balance between innovation, those necessary regulations, and these complex global supply chains that define these critical, often completely overlooked markets.
This audio was created with Podcastle.ai.